Hello and welcome to this video on solving the good stones problem. Problem statement is to determine the number of good stones in a river. These good stones are defined as the stones in which if the geek steps, will not reach a never-ending loop. Each stone has a number on it representing the value of the exact step geek can move. If the number is positive, then geeks can move right, and if the number is negative, then geeks can move left. First, let's take a look at the good stones function that takes two parameters, n and a reference to a vector of integers called arr. This function is responsible for calculating the number of good stones in the river. Then we initialize a new vector dp of size n with -1 as the initial value for all its elements. This vector will be used to store the results of the solve function calls to avoid redundant computation. Then we use a for loop that iterates through each stone in the river. Inside the loop, the solve function is called with four parameters: I, which is the index of the current stone, n, which is the total number of stones in the river, arr, which is the vector of integers containing the values of each stone, and dp, which is the vector used for memoization. Next, let's take a look at the solve function. The first if statement checks if the current index I is out of bounds, that is whether I is less than 0 or greater than or equal to n. If this is the case, the function returns 1, indicating that this stone is a good stone since it's outside the bounds of the river. The second if statement checks if the result for the current stone has already been computed by looking at the value in the dp vector. If the value is not -1, it means the result has already been computed, so the function simply returns that value. If the result for the current stone has not been computed before, the function sets the value in the dp vector at the current index to 0 to indicate that the stone is being processed. Then the function makes a recursive call to itself with the index of the next stone, which is calculated by adding the value of the current stone arr of I to the current index I. This recursive call essentially checks if stepping on the next stone will lead to a never-ending loop or not. Finally, the function returns the value in the dp vector at the current index, which represents whether the current stone is a good stone or a bad stone. If the value is 1, it means the stone is a good stone, and if it's 0, it means the stone is a bad stone. Finally, the good stones function returns the sum of all values in the dp vector, which represents the number of good stones in the river. And that's it. With this code, we are able to efficiently find the number of good stones in a river. I hope this tutorial was helpful, and if you have any questions, feel free to ask in the comments. Thank you for watching.